Welcome to another exercise for the workbook statistics. This time I'm going to talk about how to calculate the classical measures of central tendency. Let's have a look at the exercise text. Here we have the sales of a car salesman over the last 10 days, which are given as follows. And we have 4 different tasks to actually perform here. First one, construct a frequency table. Second, calculate the mode. Third, the median, and finally, fourth, the arithmetic mean. Well, part 1 we're going to do because this could make some of the calculations a bit easier. So let's start with that. However, to start with all of this, at one point or another, we're going to require an ordered data set, meaning the values which are haphazardly organized here should be in an ascending fashion. So that's what we're going to do first. We order this data set from smallest to largest number. So we start with the 0, 1, 2s, 3, 4, again 4, 5, 6, and 7. Based on this, well, it's easier to do part 1, the frequency table, but it will also be much easier to calculate the median. So let's continue with part 1, the real part 1, where we build our frequency table. So for this, I'm copying already this ordered data set, and then made the outline for the frequency table. And in the first column, that one here, I'm going to put these numbers, but I'm going to put them only once. So I have 1 0, 1 1, but 2 2s. So I'm only going to write down one of the 2s and also only one of the 4s. So that's in the column values. That's those ones. Then I'm going to count the absolute frequencies. How many of these values are present in my data set? Well, as I said, only the 2 and the 4 we have twice. All the other ones we have only once. So I get these numbers. Based on these numbers, if I sum them up, I get 10 observations. Then I can simply divide all of the absolute frequencies by this 10, giving me my relative frequencies. So summing up all absolute frequencies, dividing each of them by the sum gives the relative ones. Finally, I have the cumulated relative frequencies. Here, I'm just going to sum up the relative frequencies step by step. So here, I only have the 10%, so I'm getting 10% here. Next, I'm going to add the next 10% to the previous result. So 10% plus 10% give 20. 20% plus 20 give 40%. 40% plus 10% give 50%, 50% plus 20% give 70, and so forth. If I want to know or correct whether I've done this in the right fashion, I can simply add up my relative frequencies. The end result always has to be 1. And similarly, with my cumulated relative frequencies, the final value down here, this also always needs to be 1 or 100%. Well, this already took care of part 1 as in the frequency table. And we're going to use this frequency table in part B, where we're going to calculate the mode as well. So I'm just going to copy this. And well, the mode, that's the most frequent observation in a data set. It's a slightly different interpretation if we have classified data, which we do not have here. So in this case, it's just the most frequent one. So well, let's just have a look at the absolute or relative frequencies. And here we see the 2 and the 4. Those are the 2 most frequent ones, both with the same frequency. So our mode is 2 and 4. So in this case, I actually have 2 modes, or rather a mode which is not unique. There are some textbooks which say, well, if the mode is not unique, then you do not have a mode as such. Here we're going to follow the idea a mode not necessarily has to be unique. It can be a case like this one, where we actually get 2 or more modes. Well, that was already part B, so let's carry on with part C, with the median. And for the median, I'm going to use our ordered data set again, because this will make work much easier, especially since I'm working with unclassified data. So I'm going to copy this here. That was our result from before. And whenever I'm going to calculate a median for unclassified data, I first have to decide, do I have an even number of observations or an odd number of observations? Because I have 2 different formulas here. Well, in my case, I have 10 observations, so I have an even number of observations. I'm going to use the first formula, that one. So I have to calculate 1/2 times number of observations and 1/2 times number of observations plus 1. So in this case, I'm getting 5 and 6. So I'm going to look up observation 5, which is the 3 up here, and observation 6, which is the 4 down here. I'm going to put them here into this formula. So I'm getting 1/2 of 3 plus 4. So as an end result, a median of 3.5. In other words, whenever I have an even number, I'm going to take the 2 values in the middle, and I'm going to calculate the average of those 2 values. That's as simple as this. If it would have been an odd number, I would have just picked the 1 which is in the middle, because there's only 1. Here I have 2 in the middle. I'm going to calculate the average thereof. So that was everything about the median. So we're only stuck with the final one, with the arithmetic mean. For this we have 2 possibilities. We can start as here with the ordered data set and simply go on, use the classical formula, adding up all the observations, dividing it by the number of observations. That's what we did here, adding up all the numbers, dividing them by 10, since I have 10 observations, giving me in the end result 3.4. That's a classical one to go with, but in some cases you might make your life a bit easier. That's where we could use our frequency table, assuming we have one. We're lucky, since part A was already the construction of a frequency table, so we have this here. And if we want to use this frequency table to calculate the arithmetic mean, we have 2 possibilities. Either we can multiply all the values with the absolute frequencies, add all of this up, divided by the number of observations. It's alternative 1. Alternative 2, multiply all the values with the relative frequencies and summing this up. Since the relative frequencies, each on their own, are already divided by the number of observations, we can skip this step in the end. Well, let's consider step or alternative 1 here first, which uses this formula, which is nothing else than what I explained earlier. I'm going to take the absolute frequencies, the ni's, and I'm multiplying them with the ai's, which are just the values. So I'm going 1, 0, 1, 1, 2, 2, 1, 3, 2, 4, and so forth. Sum sign meaning adding the end result up. When I have this end result, I'm just going to divide it by the number of observations, by the 10. So here it looks like this. Since if I multiplied something with 1, I can just write it down. The only 2 things which look different than before are those 2. So I could shorten my calculation a little bit in this example, giving me, however, the same end result as before. So this only makes sense if you have a lot of absolute frequencies which are larger than 1. Not only like those here with 2. So if I have like 29, 180, then I will save a lot of time using this approach. Here, it's more or less the same. Similarly, it goes for alternative 2, which we're going to take a look at here. So same frequency table. this point using this formula, which is just the value I have times the relative frequency Ri. Going to multiply those two and add all of this up. That's what the sum sign again means. So going 0 times 0.1, 1 times 0.1, 2 times 0.2, and so forth. On first glance, this might actually look quite larger than alternative 1 or the original version. But again, this might make sense if I have a much larger data set with more or higher absolute or relative frequencies. Okay, so however, if I calculate this, I will get the same result as before. So it doesn't matter which of the three alternatives you use. The last two might, however, only be usable, might only make sense, might only actually make your life easier if you have a data set which has much higher the frequencies than just each of these values once, or maybe one of them twice or something like this. So with higher frequencies, use one of the later two alternatives. If you have more or less unique values, use the first one. Well, that's it. So I hope you enjoyed this session. I say goodbye and see you next time.